procedure we've just done in a much simpler example. So the domain of f, so we'll go through it piece by piece. The domain of f is, well, it's a rational function. The only problems are where the denominator is potentially 0. So this is equal to 0, of course, if and only if x is equal to 1. So this implies the domain of f is equal to, well, it's all x, which is not equal to 1, so it's going to be minus infinity to 1, not inclusive union 1 to infinity, if we're going to write in interval notation. 2, well, x squared, sorry, no, square root of x. Standard example, the domain is all non-negative numbers. The domain of G is equal to 0 onwards. So to work out the domain of the composite, let's do it like we did this kind of more difficult previous example. We need to work out all the things in the domain of G such that G of x is in the domain of f. So we need all x in the domain of G such that G of x, so that's square root of x, is in the domain of f. So that's this guy. So let me just label everything. This is the domain of G. This is just gx. And this is the domain of f. So we've got to think carefully. What are the problems? Well, firstly, square root of x, it's always positive, right? So the range of the square root of x is equal to, well, it's this. It's one of my kind of standard examples. You can always take any non-negative value. The only problem is if I hit 1 and square root of x is equal to 1 if and only if what? Well, x is equal to 1. So what does this tell me? The only problem is at 1. So putting all this together, the domain of f composed with G must be equal to, so all x in 0 to infinity, so that's the domain of G, such that x does not equal 1. And in interval notation, that's equal to (0 to 1), not inclusive, then 1 onwards. Quite a difficult example, I suppose. You could be really, really careful. We could also have written down the function, and it wouldn't be so difficult to do it. But this function, so just f composed with G of x, if you were to write that down really explicitly, it's 1 divided by the square root of x minus 1. So you can spot the two things happening kind of pretty easily from this, but I think it's good to do it really systematically, because when you deal with more difficult examples, you want to be able to kind of break it apart very methodically in a way that you do every time. So here you could see, yeah, sure, you can't have 1 because then you get 1 divided by 0, and of course x has to be positive because of the fact you've got the square root of x there. But this is a really systematic way to do it.